Hello friends, today we are going to discuss some important formulas on the chapter solid state. What are the formula used in different competitive examination and what are their uses we will discuss today. We know unit cells generally, for all cubed type of unit cells, there are 4 types of unit cells on the basis of their lattice points are formed. What are these? Types of unit cell. What are the type of unit cells? Simple cubic, body center cubic, and face centered cubic. Last one is end centered. Generally 4 types. These 4 types on the basis of the lattice points in the particular cuboid. What are the lattice points? Lattice points in simple cubic type of unit cell, the lattice points are 8. That means 8 corner. Body center 9. 8 corner, 1 body center. Face center is 14 because 8 corner and 6 faces. End center is 10. How? 8 corners and 2 opposite face. That's why 10. Total, how much lattice points? 8, 9, 14 and 10. These are regarding lattice points. Then Z value. Z value means number of atoms per unit cell. Number of atoms per unit cell, simple cubic is 1. Z value is 1. BCC Z value 2. FCC Z value is here 3 plus 1, that is 4. And for end center it will be how much? It will be 2. This is the Z value. But for diamond exception, that is exception for diamond is 8. This is very important. For diamond crystal, Z value is 8. And for other type of crystal, it is 1, 2, 4 and 2 remaining like this. Then formula. How can write the formula if lattice points are known? The formula is like this. If A at the center, B at the corner, C at the faces, D at the edges, E at the tetrahedral bites, and F at the octahedral bites. These are the positions. By taking this position of A, B, C, D and F, how you write the formula? Taking A, B, C, D. That means formula means the simplest ratio. The formula is as A at the center, as cuboid has one center, all cuboid has one center. That's why always it will be 1A. There is no other composition. That is only A. The only one A will occupy at the center because cuboid has one body center. B8 corner depends upon number of B into how much? 1 by, let it is 1, n1 into 1 by 8 B. Here, because the B contribution is 1 by 8 and number of corner into 1 by 8. For C at the face, number of face n2 into for each face contribution is half into C. This is for C. B are the edges. Edge means cuboid has how many edges? 12 edges. Like this. So number of edges used into for each edge contribution is 1 by 4. That is which is occupied? D. Simplest ratio we are preparing. Then E are the tetrahedral voids. Are the tetrahedral voids, then it will be N4 into 2 into E. Why it is 2? Because already you know, if the sphere is N, then number of tetrahedral voids will be twice. That's why twice is 2 is multiplied. But for F is remaining same, N5 into F. Here F, that means octahedral voids is same as number of voids, N5. So this is the composition. A is to B is to C is to D is to E is to F, depending upon the number of part. How many position occupied by B, that is N1. How many position of C occupied by C, that is N2, like this. How many part of the tetrahedral voids occupied by D, that is N3. How much part of the octahedral voids occupied by F, that is N5, like this. It will be given in the question either in the form of percentage or in the form of fraction, 1/3, 2/3, or in the percentage half, that means 50%, like this. So you have to read the question. This is the general formula of the crystal using A, B, C, D, E, F at different positions. Then there is an important formula. Number of tetrahedral voids is equal to 2n. Number of octahedral voids equal to n. That is very important. Number of spheres are known, means how many octahedral voids are formed, that is n, same. How many tetrahedral voids will form, that is twice. That is very important relation for this. Then voids, we know that for if that RO, what is the meaning of RO? Size of octahedral voids is equal to 0.414 capital R. What is this? R means sphere. R means sphere and R0 is the voids. R0 is equal to 0.414 capital R, that is for octahedral. For tetrahedral, RT is equal to 0.225 capital R. This indicates octahedral voids is greater than tetrahedral voids capital R indicate the radius of a sphere and small r indicate the void size. Okay, this is the relation we have to remember. The derivation is different, but this is the formula we have to remember. Then very important thing is this octahedral voids. These octahedral voids produced by how many spheres? How many spheres required for the formation of octahedral voids? That is 6. Minimum 6 spheres required for the formation of octahedral voids. For tetrahedral voids required 4. Octahedral voids produced by how many spheres? Produced by number of spheres is equal to 6. Here tetrahedral voids produced by number of spheres is equal to 4. We have to remember this is the minimum spheres required for formation of octahedral and tetrahedral voids. Then important thing is that R and A relation. R and A relation. R and A relation means radius and edge length. For simple cubic, R is equal to A by 2. That is for only simple cubic. R is equal to root 3 A by 4. That is for BCC. R is equal to A by 2 root 2. That is for FCC. Very important. Relation between radius of the sphere and edge length. Edge length means side. Okay. Then another thing that D is equal to always 2R. What is D? D is the nearest neighbor distance. D is called nearest neighbor distance. NND, short form is NND, nearest neighbor distance. How much the closest distance? That is always equal to 2R. D always equal to 2R. Okay, this is the one important relation. Then next part is already know that packing efficiency. Packing efficiency. Packing efficiency PE for simple cubic is your 52.4% for simple cubic. For simple cubic it is how much? 52.4%, which is equal to, it is equal to how much in the form of using pi? It is how much for simple cubic? It is pi by 6. Very important. This is pi by 6. If question will be asked in the form of, or answer will be given in the multiple choice will be given in the form of pi, answer is pi by 6 for simple cubic. For this is for simple cubic. For BCC is equal to how much? 68%. 68% in the form of pi is equal to root 3 pi by 8. How much? Root 3 pi by 8. Very important. This is using pi. Then for FCC is equal to 74%, means maximum space occupied by sphere FCC type. The vacancy is unoccupied space is less. 74% using pi is equal to how much? It will be root 2 pi by 6. root 2 pi by 6. That is, in terms of percentage will be pi by 6. This is fraction. This is in the form of fraction. This is in the form of fraction. This is in form of percentage. Okay. Very exception for diamond. For diamond, very important. For diamond like this. For diamond, Z value is 8. But other type of unit cell, Z value is different. Similarly, for diamond, that packing efficiency is equal to how much? It is root 3 pi by 16. How much? Root 3 pi by 16. That was this much of fraction. In terms of percentage, it will be how much? By 2. That is 34%. You see, compare BCC. Root 3 pi by 8. It is root 3 pi by 16. If root 3 pi by 8 is 16%, then root 3 pi by 16 will be half of 68%. That is how much? 34%. Very important for diamond. For diamond crystal, the packing efficiency is 34%. This is regarding packing efficiency. Then next part is radius ratio. This is your packing efficiency. Then we will discuss a radius ratio. A radius ratio always is equal to R plus by R minus. A radius ratio always equal to R plus by R minus. R plus by R minus. Kata into anion ratio. And a radius ratio is related to coordination number is like this. There is one table. You have to remember this data. What is this? If radius ratio 0. How much? 0.155. If 0 to 0.155, then this is your radius ratio. This is your coordination number. This is your set. The table. If radius ratio 0 to 0.155, coordination number will be 2 and shape is linear. Linear means straight. Then 0.155 to 0.225. That is coordination number will be 3. Triangular set. Then 0.225 to 0.414, coordination number will be 4. That is tetrahedral, TH short form. 0.414 to 0.7, how much? 732. 732. 0.414142 to 0.732, that is 6 octahedral. Then 0.7321, that is 1, that is 8, and that is cubic pattern. So this is the radius ratio. What the relation shows? If radius ratio increases, that means if cation size increases or anion size decreases, coordination number increases and the shape also changes. The shape of the crystal depends upon what? Radius ratio, coordination number and shape. Everything related. The next part is very important. That coordination in close packing, coordination number. That is coordination number. Coordination number for one dimensional 1D. 1D is always 2. 2. For one dimensional, coordination number is 2. For two dimensional coordination number will be 4 or 6. 4 means it depends upon the arrangement. For example, if it will be like this type of packing, here coordination number, suppose if you put another one, you can see the difference. Here, if you see, this is the central sphere. How many sphere is directly touched? 1, 2, 3, 4. Because these are not touching to the central sphere. Directly touching 1, 2, 3, 4. So coordination number 4. If the arrangement is like this, already it is discussed in the previous lesson. If you have not seen, please watch the previous videos in solid state. So this, if the packing is just at the depression, if spheres are placed at the depression point, not horizontally vertically, at the depression point, you see this is the central sphere. How many spheres are directly touching? 1, 2, 3, 4, 5, 6. So that's why in two dimensional the coordination number will be how much? 4 and 6. For if you see for 3D, same type of pattern for 3D, it will be 8 or 12. For 6 it will be 12. For 4 pattern it will be 2D pattern 4. If it will be same type of arrangement becomes 3D, it will be 8. 4 will become 8, 6 will become 12. And that 8 and generally 8 indicates coordination number 8. That is your BCC pattern, body centered pattern. And coordination number 12 indicate your cubic close packing or hexagonal close packing. Cubic close packing or hexagonal close packing pattern, the coordination number will be 12. So you have to remember regarding the coordination number. Then another thing is, very important thing is left. That is density. Density of crystal. Density of crystal formula is rho, which is equal to mz upon n0 aq. What is this? M means mass of the crystal, whether atomic mass or molar mass. Z is the number of atoms per unit cell. N0 is the Avogadro number. A is the size or edge length, or that is side, length of the side. So mz n0 aq, and the unit is always, this formula always unit is gram per cc, gram per centimeter cube, gram per centimeter cube. That is your rho value. Then okay, next, that elements of symmetry in a cube. Elements of symmetry in a cube. What are the symmetry elements in a cube? First, let us point symmetry. These are the symmetry. Point symmetry. Point symmetry. Point symmetry means if you take one cube, this is the center of the cube, you think in 3D space, 3D pattern you just observe in 3D way. This is the center of the cube. This is at this point, this is the through this point, only one. So point symmetry will be only one. Only one point symmetry. There is no, because this is the common point for all sides. That's why one point symmetry in a cube is one. Then next is axis of symmetry. Axis of symmetry. In axis of symmetry, taking the cube, it depends upon the view. First is twofold. Take twofold. Twofold means you take the cube, then you have to imagine then axis of symmetry through particular axis in twofold means you have to take the edge. This is the one. What is this? Middle of the edge. This is the middle of the edge. Just join. At this point. So this like this, how many axes can be drawn? Cube has total how many edges? 12 edges. 12 edges. Cube has 12 edges. If you see the cube, it has 12 edges. 12 edges and 2 edges will be common for the axis. So how many axes can be taken? It will be how much? 6. So answer will be 6. This is the one example. Another example like this. In different way if you draw, it will be 6 axes. 6 way you can form the symmetry. The symmetry is possible in 6 ways. That's why in twofold pattern. But if you take threefold pattern, threefold means, what is the meaning of threefold? Threefold means you have to take which one? Corner. You have to take the corner. Corner. This corner to this corner. You draw, just draw. This one. So how many corner? Cube has how many corner? Cube has 8 corner. So 2 corners used by the axis. So how many fold is possible? 4 fold. So 3 in 3 fold, how many axis of symmetry is possible? 4 types of axis of symmetry. In 2 fold, how many axis of symmetry? 6 axis of symmetry. Then fourth one, that 4 fold. In 4 fold type of axis of symmetry, 4 fold means you have to take the face. You have to take the face. Face. Suppose this is the face, this is the face. Just take. Face to face. Face to face. So, as joining face to opposite face, that is 4 fold. Joining two opposite corner, 3 fold. Joining two opposite edge, taking two opposite edge, that is 2 fold. 2 fold, and that is always 1 fold. Because only one center, body center. So always 1. In axis of symmetry, it will be either 2 fold 6, 3 fold 4, and 4 fold will be how much? As it is face. Face has how much total faces in the cube? 6. So it will become 3. By 2. Always become by 2. 6 faces, 3 types of fourfold symmetry, and threefold, that is 4 types, like this. Then the last one is we will discuss, that is plane of symmetry. This is axis of symmetry, then plane of symmetry. In plane of symmetry, we have to think like this: plane. How can we make the plane? Suppose you join this at the middle point. This is the middle point. By taking, watch. Imagine just 3D view. This is a whole cube divided. At this point, the cube is divided. How many rectangle type cuboid is formed? 1 and 2. So, just you think like this. How many it is possible? Suppose in this way it is one partition. In this way another partition. Another 3 axis. As 3 axis. Just you see. This is your cube. If you take these sides, this pattern you take, this is one division. That means upper half equal to lower half. Upper half of the cube equal to lower half. Similarly, other direction. How many possible? How many types possible? This is called plane of symmetry. Plane of symmetry taking rectangular plane. Rectangular plane. Rectangular plane. If you take rectangular plane, it is possible how much? How much possible? 3. 3. So, 3 is possible. Because this is one direction, this is one direction, other side is direction. Like this, 3 ways you can divide the whole cube into different rectangle. This is one rectangular pattern, this is rectangular. Rectangle means this is one rectangle. So, 3 ways we can divide this. That's why plane of symmetry, how much in cube? 3 is rectangular plane. Similarly, another plane is possible, that is diagonal plane. Diagonal plane. Diagonal plane. Diagonal plane means you draw the cube like this. Diagonally means you join just like this. Diagonal means join 2 diagonal like this. Just you see. These 2 corner A, B, C, D. This A, D diagonal, one diagonal of this. What is figure? This is the figure diagonal. This is the figure diagonal. So this figure is produced. This one. Imagine this one. This one which is produced 3D. How many types it is possible? How many? Just to think. How many corner? 8 corner. Total is 8 corner. So 8 corner. If you see the diagonal, you see. How many diagonal is possible? Just to take. How many face? Total face is how much? Total face is 6. Just to see. Total face are 6. 1, 2, 3, 4, 5 like this. 6 faces. 6 faces. How many diagonal is possible? 1, 2. Each face two diagonals. Each face two diagonal. So total face 12. So 12, and for taking two, how much produce? One plane is produced. Plane, we are discussing plane of symmetry. So taking two, one plane. So total is 12. So answer will be 6. 6 plane is possible. Taking this, if you draw what? Taking the diagonal, opposite diagonal, this is 1, like this, if you draw like this, it will be possible how much? 6. So diagonal plane, how much plane of symmetry? 6. Rectangular plane, how much plane of symmetry? 3. And axis of symmetry, 2-fold 6, 3-fold 4, 4-fold 3, decreasing, 2-fold 6, 3-fold 4, 4-fold 3, just decreasing, 6, 4, 3. And just you see, plane of symmetry, rectangular only 3, but diagonal it will be more. Then first one is point of symmetry. Point of symmetry is always 1. So like this, different types of symmetry elements also possible in the cubes. Okay, in the next class we will discuss some important JEE NEET problems in this chapter solid state. Okay, thank you.